Everyone, this is Deep Barot from team A6-6. This is a part of the assignment of class CS6310, and this is assignment 6 final project presentation. In this presentation, I'm going to describe you the architecture diagram, architecture decisions that we made, and the main three modules that given to us. The first one was configurability, the second one was authentication authorization, and the third one was scalability. And I will walk you through the step-by-step process what we did gathering requirements to have a brainstorming session with the team members, getting a feedback from the instructors, and then how we came up with the design that we have. Okay, so to start with that, I will walk you through our GitHub code. And in GitHub, you can find the README file which explains why, um, what are the technologies that we are using and how we are integrating. So I will provide you the quick overview. So as a part of this assignment, we are building a streaming wars application. In that application, there are many stakeholders like studios, streaming service providers, demographic groups, and admin. And admin has all the access to add a studio, add a streaming service. A demographic group has a role. It is a role, and it has a permission to create a new demographic groups or watch a movie. And I will walk you through the more details in the presentation. So, in this entire application, there are three main components if you think in perspective of the architecture, which is a front end, back end, and database. For the front end technologies, we are using React. Um, Along with Bootstrap and HTML. In the backend, we are using a Spring Boot applications, and in a Spring Boot, we are using a Spring security module as well as Spring Data JPA, and that is taking care of a heavy load for us. And then we have a database Postgres in this one. For dependency management, we are using Maven. Okay, so without waiting a lot, I will explain you through the code we have. So here is a Spring Boot applications, and whenever you see Spring Boot applications, first thing is pom.xml, and in a pom.xml it describes all the dependencies we are using. So we are using the Spring Data JPA, Java Persistence API, Spring Boot Starter for our REST API and Web MVC, as well as OAuth2 server for authentication, and same for security. And we are using a Postgres integrations, and I will provide you the details where we have where are the configurations for connecting to the database. Because we are using Spring Data JPA, it is taking care of many queries and security from the database side as well. This is the application.properties file, which can be found under the properties folder, and um, over here, this is a connection URL, a username, password for the database, and many more stuff. And this can be overwritten by the Docker compose variables or Docker variables, which we will explain later. The flow of the diagram is this one, where we have multiple modules, and I will zoom in and I will walk you through that. So Spring Security comes in place first. So whenever we run the application, Spring Security comes in, means login screen comes up. When user logs in, there are two things happens: authentication and authorization. When user logins with the correct username and password, it allows user to log in, but also it checks which role user is carrying. Means if user is admin, it allows all the access, but if user is a studio owner or demographic service, then it will not allow to do certain operations. Then once they log in, it makes a REST API call from the front end, or we can call this API with the proper session token, and this controller is the entry point. So this is the controller. So I will walk you through the studio controller we have. And if you see over here, so we have a REST API which we are mapping to the /studio endpoint. And here we are using get, post, put, delete methods, those verbs for creating, updating, editing, and deleting studio objects. And if you see over here, we are doing verification if his user is authorized or not based on the role. And if it is not, then it sends the error code with unauthorized. If it is valid and if it matches all the criterias, it is returning okay, otherwise it will send not found. Over here it is very important because we are doing a data validations over here based on the requirements. So this is a very important feature. So once developer or once user makes a call from the front end with a valid session token ID, it first comes to the controller. Controller passes that information to the service, and when we click on service, uh, it is a business logic section where all the logic can happen. So if you can see over here that this is the business logic we are adding for updating a next month or updating a calculation, and here is the comment which describes the purpose of these methods. And then we have the repository, and repository has the methods required to do certain operations with the database. And because it is a Spring Data JPA, so we are not writing hard-coded SQL queries. And this is a good way to have queries, so it avoids or it saves system or applications from the SQL injection and many other security flaws. So if it is a Java-based query and there is no plain SQL written over here, and this is a parameterized query. And for more operations can be found in a CRUD repository where it provides other options like exist by ID, delete, or delete all. So we do not need to write common boilerplate code. So that's how we save logic over here as well. Um, we have a models over here, and models are the important one that are mapped with the database. So in the model section, if I look at the studio, and this basically says that this table is mapped with the table name studio in the database, and here annotations we are giving and saying this is the column name in the database, and that's how the fields are mapped. And this is very important aspects, and this is for encapsulations. And so in this project we are using all the object oriented programming concepts, as well as we are using the Spring Data and Spring Beans for the dependency injection. So this is how our application look like, and as I mentioned, this is the entry point applications.properties file. So that's how we run the application. Okay, now let me walk you through and this is the entry point. The next piece is authentication. So as I mentioned, when client tries to log in, it talks to the backend server with a correct username and password, and if user it is a valid, those passwords are encrypted in database, so those are safe. And once the user has a valid username and password and with a valid role, it returns the session ID, and that session ID user carries with it until the session expires. And that's how OAuth architecture is applied in this program. We are using the Spring Security and Spring OAuth server. So in that case, it adds those functionalities by default. But if you want to see more details on the Spring Security, then there is a class called Web Security Config in the code, and you can read through it. What are the roles we have and how are we allowing some of the things over here. And we are using annotation enable web security. On top of that, we have so the first part was configurability. For that, we have a front end application that my friend John going to explain in a few minutes. The another point was authentication, which I explained, and the last topic is scalability. And this is basically like how we are planning to scale these applications. So as I mentioned, we divided this entire application into three components, which is a PostgreSQL, backend and front end, and all three are running as a microservices. Means Postgres has its own container and volume, so we can persist the data, and it can be start and stop. Same for the Spring Boot application, which is wrapped in the separate Tomcat container. And this React application is wrapped around Nginx container, and which I will provide details soon. But because we have a microservices over here, it is very easy to scale horizontally and vertically. Here we are only talking about the vertical scaling though, and horizontal scaling. So horizontal scaling means you can create multiple replicas of the particular services or the containers. And because we want to achieve a high scalability, we use the Docker as a technology to achieve that goal. Other than that, we are using the Docker Swarm to orchestrate Docker containers. And why we are using Docker Swarm? Because once you have only one copy of Docker containers, it provides you the portability and more manageable resources. But when you have more than one replica of each services, then it becomes difficult for you. And in that case, you need Docker Swarm. So we are using the Docker Swarm, and that provides us a decentralized access, high security, auto load balancing, high scalability, and rollback feature. And the way Docker Swarm works is it has a registry, it has a Docker client, and it works as a like master node and the worker nodes. And master node does all the orchestrations, and run those containers. If something fails or one container fails, then Docker manager has a service, and that service is keeping track of all the nodes. And if any container or node is down, then the Docker service initiates the task or schedules the task and spin that container up. So it allows us to get a high scalability or high availability of our application, and it takes care of the automatically management of the all the containers. So let me walk you through the some commands that we are using over here. So over here, so I will just walk you through the application Docker file we have. So Docker file is a configuration file to spin up the Docker containers or build Docker containers from the Docker image itself, and add more details to it. So these are the Docker containers for backend. This is for database, and here we are saying this is a database username and password, and initialize the script over here, expose port, and these are the basic information of a Docker file. Over here, Docker Compose is explicitly we are saying that run on this port internally and externally, and we are providing some variable names, and here we are overwriting some of the parameters like username and password. This can be pushed through the HashiCorp's uh, vault mechanism to avoid like a hard-coded username password, but for the simplicity we kept as it is. And you can see over here, for this is the configuration for our front end, and this is the configuration of our database. And for the simplicity for this project and for our TA friends, we created this shell script. So that's what we are going to ask you to run it. And what it does basically, it is a Docker Compose down -v, means it brings all the containers running down and make sure the volume is wiped out to start fresh. And it is Docker service remove registry, because we are using Docker stack based Swarm deployment. So that's why we are asking to remove the registry as well as the stack demo. And then here we are like asking to create all the images one by one, front end, back end, and database. This is a Docker ps command, and this will list out whatever the running services it has. And then we are using Docker Swarm in it, and then we are setting up the service. We are just checking what's inside the service, and then we are pushing the images as well as running through the Docker Compose file. And that's how we set it up, Docker stacked base Swarm instance over here. We will try this thing at the end to run the multiple replica of the front end application, and that we will take later. So once we run through this project, it will look up something like this. It will go to the login screen. So let me stop and run the demo over here for you. And so you should be able to run project shell script, and it will go through all the steps. And yeah, and I will explain step by step. And here it is trying to stop existing running application, and removing the services as per the command. And currently it is because the other containers were running, so it threw error. And over here it is building the front end for now, and you can see over here. So these are all the steps that mention into the front end's Docker file. And now once it is done, it is going to start building a backend. And in the front end Docker file, if you can see, so it is doing a yarn install, and that's where it takes some time to download all the dependencies and build from scratch. And that's we seen over here. And now it is trying Maven clean install for the backend. So here our Docker file looks like. In this Docker file, it is doing Maven clean install, and then it is setting up Maven and uh, open JDK and setting up the jar file over here. And once it is done, it will pick it up the Docker file DB. And yeah, it compiles the code once it is. So that's what it is running Maven clean install, and we are skipping the test right now. Okay, so seems like it is done. Um, and now the database, and yeah, so it ran the Docker swarm in it. So when it runs the Docker swarm, it says that this is a manager node. And once it says it is a manager node, you can spin it up other Docker worker nodes, and you can run Docker swarm there. And that's how it looks like. So if I do the Docker PS, it will show me all the 4 copies of it, like front end, back end, database, right? And now if I go to the front end and type localhost 8080, it brings me to the login screen. And if I login, it brings me to the home screen, and over here I can see the home screen. More front end details will be provided by John. Okay, thank you. And yeah, one more stuff over here. If I want to run multiple replica to scale it, scale it horizontally, I just need to copy this command and just run on the fly, and it will spin up more containers of it. So for example, I want to, so over here, if you see, if I can put a Docker service ls, and it provides me what are the service it runnings, and you can see the replicas over here. And to scale it, I am saying that I want to scale high and put it the API to 3, and click it. It will spin up all three instances of this API, and I will be able to check by Docker PS, and I will see 3 copies of my backend running right now. And that's the beauty of Docker Swarm. You can scale on the fly, and if I want to scale it down, I can just make it down. And we can make more dynamic scale up and scale down based on the traffic. But this is the charm of our orchestration tool that we are using. So yeah, that's pretty much it. Thank you.